Hello, this is the fourth and last segment on random walks. We ended the last segment with the observation that the distance from the origin seems to grow with the number of steps, but that we didn't have any good intuition about quite how fast. I want to start today's segment by drawing a plot that will give us some intuition about that. If we look over here at the code, we'll see that I've replaced drunk test by something called drunk desc P. This is essentially the same as drunk test, except rather than printing something on the screen, I'm producing a plot. Also, to simplify the plot, I'm ignoring the maximum and minimum distances and only plotting the mean for each trial. Let's run it and see what we get. As expected, we can see that the distance does grow fairly significantly with the number of steps. And now if we stare at it, maybe we can get some intuition. Let's look at this one point way out here in the upper right. We see that's almost 100 steps away and with a total of 10,000 taken. So maybe, just maybe, there's a relationship between the square root of the number of steps and the distance. Let's write some code to see whether that seems to be true. So now we can look at drunk test P1. It's like drunk test P, except in addition to plotting the distances, I'm going to just plot the square root. So that we can tell them apart, I'm going to put the distance on a blue solid line, and the square root is going to be on a green dashed line. I'm going to use appropriate labels and then produce a legend so that we'll be able to look at the graph and see what it means. Let's run it. See what we get now when we run drunk test P1. Sure enough, the two of them seem to track. They're not identical, but they're pretty close. It does appear that the mean distance is just consistently a little bit less than the square root. We could think that perhaps that's a result of just randomness, but I've done this a lot of times and it seems to be pretty consistent. But I'll leave it for now as an exercise to the student to try and think about why we might have this small but consistent difference between the mean distance and the square root.